Okay. Now we'll do use vesting program. And then the query is going to be for the vesting accounts. Okay, so now you can see we have close, decrement, increment, set. This is everything related to the counter. So we can just delete that. Okay, and we'll delete the corresponding returns. Okay, so now we're going to want to add in creating an employee vesting account. So this is going to be very similar to our instruction above. So what I'm going to do is just copy this over to make things easier. Okay. Now, instead of create vesting args, we're going to create an interface for create employee args because these are going to be different. When you're creating an employee account, you're specifying things like the start time and cliff time of your vested tokens. Okay. So interface, create employee args. Okay. Now we'll define what that is. We need the start time, which is a number. We need the end time, which is also a number. The total amount, which is a number as well, and then the cliff time, which is also a number. So those are our 4 arguments needed when you're creating an employee account. Okay, so we can go back to our create employee vesting. We'll update this to employee account. And then we're passing through the arguments we just defined. So start time, end time, cliff time, and total amount. Okay, and then we'll update this to create employee accounts. And that is going to take in the start time, end time, total amount, and cliff time. Okay, and now the accounts. Let's go back to our bank run tests and just check to see what accounts we need. So accounts, test, bank run. So one good thing about testing in TypeScript when you're creating the front end, it's very similar. So it makes things a lot easier because you can always reference your tests and you know that these work. For creating an employee account, you need the beneficiary and the vesting account. So we'll go back to the data access and we're going to update our employee args to include the beneficiary, which is going to be a string because it's going to be a user input. Okay. And then we'll go back and do the same thing to convert it to a public key. So this will be beneficiary, new public key of the beneficiary. And we'll update that here. Okay. And now we don't need the token program, but we need the vesting account. And that is just the account. So now we can return the create employee vesting. Okay. Great. So for now, this is what we need for our data access. Let's update our UI and then the feature. So let's rename this to vesting UI. We need to update all of our imports. So let's just go through everything here. And we also need to update the data access file name. So we'll change this to vesting. And while we're here, we can update some of the unused imports. We no longer using a key pair because we're connecting to the wallet rather than generating a key pair. And we're no longer using program. Okay. Okay, so we'll update the create to vesting create. And then we're using the create vesting accounts from use vesting program. Now, this is what the UI is going to look like. As of right now, it was just a button that you clicked for the counter. However, we need to accept some user input parameters. So we're going to have to change that a little bit. So first, we're going to need the company and the mint. So let's actually update this to have the company and then set company. And we're going to use state. Okay. And we're just going to import this from React. And then we also need to do the same for mint. Okay. And now, because we're using the wallet that's connected, we want to be able to get the public key from the wallet. So const public key. And this is going to be use wallet. And this should be an import from the Solana wallet adapter. And you can see that updated the import. Okay. So now we have that set up. Now we need to be able to get these two values from the UI. So let's create a text field for both of those. So in the return, we're actually going to create a div. And we'll put this button inside the div. Okay. So now we'll have a text field. So we'll do input. And let's just take what Copilot has, and we can update it as we need. So we have the type is a text. Good. The placeholder is company name. Good. The value is company. And then on change, we want to set company. Okay, great. Now let's also add in the class. So we'll do class name. And we're just going to define this as an input. And we want to have a border. We want the width to be full. And let's do max width for extra small. Okay. There we go. So that's our first input. Now we need another one for the mint. Okay, we're just going to accept what Copilot's suggesting and then review it. So we have the input type text, we have the placeholders, the mint address, the value is the mint, it's updating the mint on change, and then it's taking the same exact class name from above. Now let's update the button. Well, we can change the name of the button, and that'll be create new vesting account. Okay, now we're going to need to do a little bit different than how the counter is. And that's because we have some values that are being input. So we want to make sure that those are added from the user. So we're going to actually check the form. So let's do a few steps before we actually update the button. So first is we want to make sure that the form is valid. So let's do const, we'll do an is form valid check. And we just want to make sure the company dot length is greater than 0 and the mint length is greater than 0. Okay. And now we're just going to do a handle submit. So let's do a const handle submit. And we're going to do if So we want to make sure, 1, the wallet's connected, and 2, the forms are valid. So if the public key exists and if the form is valid, then it's going to run create vesting account dot mutate async with the company name, which is the company, and the mint. Okay. And now we just want to do one more error handling, and that's just if the public key doesn't exist, we want to return an error to tell the user to connect their wallet. So we'll return connect your wallet. Okay. So now that those checks are in place, we can just update what happens on click for the button. So on click, all we're going to do is just handle submit. And then it should be disabled if the create vesting account is pending, and it should also be disabled if the form is not valid. So a user cannot click the button unless they've fully filled out both of the forms needed. Okay. And then we'll just update the button to have create vesting account is pending. And there we go. So now we've updated the vesting create page. Now we need to update the list. So what this does is it returns a list of all of the vesting accounts that are connected to the connected wallet's public key. So if I created multiple vesting accounts because I'm separating my company into separate mini companies and I want a vesting account program for each of those, it'll show all of them. We're going to update this to have use vesting program. And now what this is doing is it's checking the data of the program account. If the account is not found, it's going to return an error and say you need to make sure that the program account is deployed to the correct cluster, meaning if you're connected to LocalNet, the program should be deployed to LocalNet. If you're connected to DevNet, the program should be deployed to DevNet. So now you have the return and it has your cards. So this is going to be all of the cards associated with the vesting account. So we're just going to rename this to vesting card. And then we'll find where the counter card was originally written. Okay, and we're going to update this for vesting. So this should use vesting program. Sorry, this should be use vesting program accounts. And it takes in the accounts. And now we'll update this to have create employee vesting. Okay, so this we're going to make updates very similar to the previous section because we're going to be taking values from the front end and using that in processing our instructions. So let's set up all of the information that we need. We'll need the start time. And now instead of using state as a string, this is going to be a number. So we'll update that to a 0. And we'll do the same for end time, the same for total amount, and the same for cliff time. Okay. Now we're also passing through the company name, but because we're connected to the account, instead of needing to pass that through on the front end, we can just query the account because the company name is saved to the account state. So we're going to do const company name is equal to, and we'll do use memo. So we'll do an account query of the data in the account. We'll unwrap that and find the company name. Okay, and then we'll just need There we go. Okay, so we can remove this because that's coming from the counter. And that was just querying the count from the counter state. So we're doing basically the same thing, but querying the company name instead. So now we'll update the UI here. So we have, this is separating everything into cards. And we have the header. This is just querying the account. So from the account, instead of the count, we want the company name to be the header. Okay. Now, before the buttons, we're going to need a text input. So we're going to do basically the same thing we did above. So for simplicity, let's just copy that over instead of having to write it all out. Okay. So we'll make that update under the header and then under this div. So this div is separating all of our buttons. So we have an input. And this will be text. We're going to set this as start time. The value will be start time. And now we want the start time placeholder to show. So because of that, we're just going to do this. Okay. And now we have the value on change. It's going to set the start time. And this is going to be, because this is a number, we're going to have to parse the integer. So we'll do parse int. There we go. And we'll keep the class name the same. So now we're going to do the same thing for the rest of the inputs. So we'll just copy this and update this to end time. And this will be set end time. Okay. And then we'll do the same for cliff and total amount. So total amount comes first, actually. And we'll set total amount. And then we'll do cliff time. Okay, so let's just make sure we did all of that. So start time, set start time, end time, total amounts, and cliff time. Okay. And let's just write allocation here so it's easier on the front end so you know what that value is. It's the total allocation an employee gets. Okay, so now we can update our button. So the button, it'll have the same class. On click, we want to create employee vesting. And that is going to update these arguments to start time, end time, total amount, and cliff time. Okay. And then we'll update this to create employee vesting. Okay. And now we're getting an error, so let's figure out why. So you can see beneficiary is missing in the type. So we actually are forgetting one field. So let's update this to also have the beneficiary. So here we're going to need const beneficiary, set beneficiary, and beneficiary is a type string, so we're going to use the string. And then we're going to need to have an input field for that. And this will be a beneficiary. And this will be the wallet address. Okay. We'll update this to just beneficiary. And this is not an integer, so we can get rid of the parse int. Okay. And then this should be set beneficiary. Okay. And now we can pass that through as well. Okay. And we'll update the name of the button to create employee vesting account. And this we can get rid of because this is coming from the counter program. And we'll just clean everything up. Okay, and we'll clean up our imports. Anything unused we'll get rid of. All right, so lastly we need to update our feature. So the counter feature is going to use the vesting program. It's going to use the vesting create. Let's update our counter list to be named vesting list. Okay. Then we'll update everything for vesting. So this should be a vesting feature. Okay, this should be vesting create and vesting list. Okay. We'll update the title to vesting smart contracts. Actually, we'll just name it token vesting. Okay. And then create a new vesting account. Below. And we'll just remove the rest of these comments. Okay. So let's see. This is our feature. We're setting up the vesting feature. We're connecting the public key from the wallet that is connected to the front end. We have the program ID from our vesting program. If there's a public key connected, it'll return to create a token vesting account. Okay, so this looks like everything we need. We're just going to rename this vesting. And now we should have gotten rid of almost everything related to the counter by now. There's just one more thing we're going to need to update. So vesting, let's just Command-Shift-F for counter. Okay, these are all just comments. So here we go. In the layout, we'll update this to vesting program. And this should be using the vesting path. On the page, we want to use the vesting feature. And we're going to import the vesting feature. Okay. These are all comments. Okay. And now let's just update our queries to vesting. Okay, so now we're good to go. So now to recap everything that we've done so far, we've created our smart contract using Anchor in our Anchor workspace. We've built the project and deployed it also using Anchor. We deployed onto our local host, so we're running a Solana test validator locally on our computer. And then we've updated the front end to be able to connect to our wallet and execute smart contract instructions. Now that all of that's done, we're going to run on our local host, the UI, and be able to test it out. One thing to note before we start running, you're going to want to make sure that your package.json, the lock file, is updated. because it's probably still going to have dependencies linking to all of your accounts or files. So I would just delete the package.lock and rerun npm install to make sure that everything is set and good to go. And then we can just go into our web folder. So we'll cd into web, and we can run npm run dev and get this running on our local host. Okay, so we're gonna open up our browser, navigate to our local host. Okay, so this is what our UI looks like using the Create Solana D app. You have the cluster that you're connected to. You can see here we're connected to local. You have your wallet connection here. And this is connected to my Phantom wallet that I have linked on this webpage. Now, you can see that it automatically prompts you that I'm on local, but I don't have an account found. So I'm going to request an airdrop. So this account that my wallet is connected to is now funded with Sol, and the account exists. So this is our placeholder. You have this basic front end that has just GM. This is your new Solana D app and some links. Now, what we updated was the vesting program tab. And just to make sure you're familiar with the Create Solana app scaffold, we'll just go through all the other tabs first. So you have this account tab. And this shows the account that I have connected. Here's my wallet address. It is the same as the wallet that's connected. You can see that I have one Sol that I just airdropped to myself. You can see the transaction history, which was the Sol that I just airdropped to myself. You can see that I have no token accounts currently. And you can see that we have the option to airdrop, send, and receive funds from my wallet. Now we can move on to the clusters tab. And these are all the clusters that you can connect to from your front end. So you have DevNet, you have LocalNet, and you have TestNet. Currently, we're connected to local, and we're running our local on our Solana test validator in our terminal. You can see our status of our current validator. Here's the process slot, confirm slot, finalized slot, and full snapshot slot. So you can see everything's running correctly on our local host. All right, so now we can go to our vesting program. You have the name, token vesting. It says create a new vesting account. This is the program ID of the account that we just deployed. Now let's test this out, but we're going to need an correct mint address for this to work. So we're going to go back to our terminal, open a new tab, and we're going to create a mint on our localhost. So let's do SPO token, create token. I'm going to specify the URL to be your local host. Okay, so you can see we're creating a token under the token cake program, so it's an SPL token. Here's the address of the token we just created, and there's the signature, so you know it was a successful transaction. So we're going to copy that address, go back to our UI, and paste the mint address in the mint address field. Okay. Now we'll do the company name, so we'll just name this Bootcamp. Okay, so we'll create a vesting account, unlock, confirm the transaction. Nope. Great, so now you can see the new vesting account that was created for the Bootcamp. And this allows the employer to now come in because this Bootcamp card from the new vesting account that was created is connected to the public key that I'm connected to on the UI. So all of the vested accounts that I create are going to show up here, and then me as the employer is able to come in and create employee vesting accounts for employees for each account that I create. So if I wanted to make another one, just like a subset of vested tokens, and I set this as my 2024 Bootcamp employees. We're going to just create new vesting account, confirm. Now you can see this is my other set of vested allocated tokens. Sorry. you can see this is my other set of vested tokens. So now I'm managing 2 different accounts that have separate tokens. I could create a separate mint address if I wanted to, so we can actually just test that out. I'll go back to the UI. I'm going to run SPL token create token. Now I have a whole new token. So let's say I wanted to have some employees vested with one token and some with another. I can do that. And we can do just a test here, create a new account, confirm. And now you can see, here's my next account. So this is related to one token, and this has a mint address of another. So now I can keep track of all of the vesting accounts that I create, and within those, I'm now able to create employee vesting accounts that have a start time, total allocation, end time, cliff time, and the wallet that I want the beneficiary of this account to be able to claim tokens. So there's my UI, and you can see everything works with the program that we created. And overall, we created a smart contract. We tested it using Bankrun. We updated the front end with our Create Solana DApp scaffold, and we tested it on the front end. We also deployed our smart contract to our local host while we're running our Solana test validator locally. So there's our token vesting DApp.
Now that we've been building with tokens, we're going to add something new in our next project. The next project will be a token lottery system, where the user will be able to enter into a lottery with a smart contract acting as the ticket issuer. The hard thing about lottery systems and blockchain is that they require some amount of randomness to be fair. A distributed system coming to a decision on a fair random number is impossible, so we're bringing in a new concept to help us out. In blockchain, oracles can be used to retrieve random numbers for use cases on-chain. Oracles connect the distributed system to the data of the outside world, financial data, football game outcomes for betting markets, or even random numbers can be retrieved from these oracles. The way these oracles work is that they have a distributed set of data providers from the outside world pushing data on-chain. The on-chain data is then normalized within your smart contract, throwing out data oddities and taking a fair number based on the data provided. Random numbers are still difficult even with oracles, but they can be retrieved using a commit-reveal scheme. First, someone will commit a random number that is hashed with a random seed value. This commit value can be stored on-chain for use later. Once ready to reveal, the original committer will then push both the random number and the seed value, which can be verified against the original hash. We're going to do exactly this commit reveal scheme in our project. Let's get started. All right, so for this project, which we have called the token lottery, what we're going to do is we're going to have a lottery system that people can buy tickets from. They can use those tickets to then claim prizes, and then we're going to use something called off-chain randomness. So it's not actually on-chain, it's using something called oracles to decide the winner of the specific lottery. So let's get started. Before we do any code, what I'd like to do is I'm going to draw up all the different things that we need to build. So we're going to design our program. So this is the token lottery, right? The token lottery is going to have a few functionalities. So we have issue ticket. We are going to be able to, let's say, we're going to have to be able to do a commit reveal for randomness, and finally claim prize. And so thinking about this, what kind of instructions do we need? So let's start building out and designing our program. So the first instruction we obviously need, we're gonna have to create the configuration for the lottery. So this is gonna be a initialize config. So that will build everything that we need to for that lottery. The next thing that we might need is we might need a initialize lottery so that we can create all the different pieces for creating our collection, being able to issue tickets later, etc. Because we want to make sure that we initialize the lottery collection first before we can allow people to buy tickets. The next one, this one's going to be something that's going to be done by the user of this, but we're going to do a buy ticket function so that people can buy those tickets and then they can later use those to claim. So we're going to get into this a little bit later, but we're going to have two separate instructions. One's going to be a commit function, so commit randomness function, and the second one will be a reveal randomness, or choose. We'll call this choose winner. The reason being is whenever you do like a commit reveal type of scenario or scheme, you have to make sure that you do those in two different instructions, specifically also two different transactions. You cannot do the commit reveal both in the same transaction because there's some gaming that you can do there. And the final instruction that we'll need is claim prize. So claim prize. So you can see there we have six different instructions. You can already kind of think this is going to be a pretty thorough and in-depth smart contract that we're going to be building. Let's figure out what that config is. So we're going to call this the token lottery. This is going to be everything about the token lottery. We're going to need things like we're going to figure out who the winner is. This will be a ticket number, basically. We're going to have to figure out if the winner is already claimed, because what we don't want to happen is someone to be able to claim the prize immediately on token lottery without anybody doing anything. We want to make sure that it's bound by the time that the token lottery is taking. And time meaning we have a start time and an end time for the token lottery. Next thing we have is we're going to have an actual winning amount. So we have to have we'll call it a lottery pot amount. This is the amount of money that is up for grabs so that people can win it. Another one that we're going to have to need is we have to keep track of the total tickets. If we don't have the total tickets, let's actually call this total tickets. So total tickets. If we don't have the total tickets, we won't be able to figure out what number to choose from for our randomness data. So we have to keep track of that. We want to make sure that we have a price for all these tickets. So if there's a price to pay to get in the lottery, that's something we're going to have to keep track of. We're going to need two things that are not really obvious, but we'll need the authority. So there's going to have to be an authority that can do the commit randomness and choose winner. Otherwise, you can't really do much with it. And then finally, you'll need that randomness account. This randomness account is just to tie the account that is required to do the randomness information. We want to tie it directly to the token lottery config. All right, so we have a basic understanding of what our instructions are going to look like. We're going to have 6 different instructions. We have our config. Let's go ahead and start building. So we're going to open up VS Code, and I'm going to do new terminal. And as usual, we're going to do npx create Solana dapp, and I'm going to type it all out. So this is going to be a lottery. We're going to call it token lottery. Token lottery. We'll call it an XJS. For this project, we're not actually going to build a front end. It'll kind of be like a challenge for you to figure out how to build that front end. We're going to do a focus on the smart contract side. Tailwind, we're going to come with the basic stuff and it'll create. So I'll see you in a moment. All right, so we have a project. Let's go ahead and open it. So we go over here. I'm going to open token lottery. There we go. We have our project. It has an anchor folder. Looks like it has everything we need to get started. Let's close all these warnings. And I'm going to open a new terminal. And we're going to do first 2 things. npm install, just so that we make sure we have everything that's needed here. All right, now that's done. Now we're going to go into the anchor folder. Let me make this bigger for y'all. We're going to go into the anchor folder and we're going to do an anchor build, just so that we make sure that it sets up everything. So right there, we saw something that we want to keep track of. It says warning anchor version 030.0 is not equal to the CLI version. So as a note, throughout this entire bootcamp, we're going to be doing it with the 0.30.1 anchor version. So we want to make sure that we set up everything to be using that. All right, so what we're going to do is we're going to go update that. So if we go over here into programs.basic, cargo toml, you'll see down here it says anchor lang 0.30.0, update that to .1. We're also going to change a couple places. We're going to change this to say, we're going to say token lottery. we just want to make sure that sets everything. This one's going to be an underscore. There we go. Actually, let's just make everything underscore just so that it's easy for us to understand and remember. So I'm going to update this. I'm going to update this. We're going to update this folder path name also just to be token lottery. The lottery. Okay. Token lottery. So let's update all the names. Let's make sure that it's set here. So there's going to be a programs here. There we go. Update that to token lottery. And then finally, we got to go into our librs and update this to say token lottery. Okay, so now we can do an anchor build. So everything completed. Everything ran perfectly, so we can actually continue. So we have our greet. It has a message of GM, so good morning. We're going to go and remove that, and we're going to go back over to our specific design diagram that we created. So here we have initialize config. So we're going to build that one first. So we'll call this instruction initialize config. We already have the context of initialize, and it's going to do a bunch of different things. Right here, we know that we're going to create an account because we have to create that specific config account. We're going to call it the token lottery account with all that data that we had over here. All right, so because we know that we're going to have a pair. It's going to be a signer. I'm going to use lifetimes here. If you don't know what lifetimes are already, I would recommend looking them up in the Rust book. They're not that hard. All right, so this is going to be account mutable because we are going to use a pair and there's going to be LAMP ports deducted from the account. And then we're going to have another account. So this is going to be account, and I'm going to enter here. We're going to initialize it. The pair for this will be pair. I'm just going to put 8 here. We're going to update that in just a minute once we create the account. Then we're going to have 2 different things because it's going to be PDA. I'm not going to do it as config. I'm going to do it as the token lottery. And because it is a PDA, we're going to need a bump. And so this is going to be a pub token lottery, and it's going to be a specific account. We're going to call this info token lottery. And because we're creating it, you can see Copilot already knows, because we're creating an account, it's going to say like, hey, we need the system program. Let's go add that system program. All right, so we have this token lottery. We have to actually define it now. So let's go define it real quick. We need an account. It's a pub struct token lottery. You can see here, it's asking us to do a bump, and we're actually going to keep that. It wasn't in our original design, but best practice, if you're using a PDA, you want to save the bump in the actual PDA. This allows you to use less compute later on. Just make sure that you always save the bump in the PDA and then use that to derive it later. All right, so let's set all this stuff in the token lottery. Before I do anything, I'm going to do the, derive, the macro for derive init space. And then because I did that, I can now go the 8 bytes for the anchor discriminator plus the token lottery init space. This will make sure that it auto-generates the amount of bytes that it takes to store this token lottery on chain, and I don't have to do some math. I always am for that. All right, so let's go ahead and set everything. So first off, we need a winner. We're going to have U64 as the ticket numbers. Next thing, let's say we need the winner claim. So this is going to be winner claimed. This is going to be a bool. Next one's going to be start time. We're going to do this in slots, which is a U64. We need the end time. We need a lottery pot amount. So pub lottery pot amount. This is going to be U64. The next one we have is the total tickets. So pub total tickets, it's going to be a U64 as well. We have the ticket price, and then we have an authority. So this is going to be pub authority. This is going to be it's going to be a pub key. Let's remove that extra space right here. And then finally, we have the randomness account, which is going to be another pub key. So randomness account, not randomness account. There we go. All right, so we have this big struct. We should have everything we need to get started. Let us start filling this in. I'm going to do a quick anchor build just to make sure that we wrote the right code and we don't have any typos anywhere. All right, everything compiled. It's great to hear. All right, so what we're going to do is we're going to start filling out this configuration. So in order to do that, we just start writing all of them. So I'm going to remove this underscore here because we're actually using the variable. So accounts dot, we're going to do the token lottery equals, we want to make the bump because we remember we always need to remember to set the bump. We're going to do context.bumps.token lottery. This is basically just going to set it in the account for the bump that was used to derive this token lottery. Next up, we have the start, end date, and price. So start, end time, and price, right? Those are actual parameters that we need to pass in. So let's go ahead and pass those in. So we have start of a U64, end U64, and price also as a U64. So we have this. We're going to have context.accounts.start time is start, end time is end, set the ticket price. We want to set the authority. So the authority will be the payer. Then we need the lottery pot account amount to be 0. It actually sets it as 0 by default, but we're going to set it just to be verbose. We want the randomness account to not be set yet. We're going to do that whenever we commit the randomness. So dot randomness account equals pub key default. So it's going to be a default pub key. Can't derive that. That's fine. And then finally, we're going to do context.accounts.token lottery winner equals, well, not the winner. We want the winner claimed equal to false. Let's do the winner. Let's change this to winner chosen just to be a little bit more understanding what we're doing because it's false. We haven't chosen it yet. We're waiting to choose it before we continue. All right, so we set everything. Let's go ahead and test it. All right, compiled. Let's go over to the anchor tests. We're going to update this to say token lottery instead of basic. So token lottery.spec.ts. And I'm going to call this the token lottery and should init config. So there's a couple of things here. What we see is this is trying to import basic. We need to import, instead of basic, we're going to have to import the token lottery. So this is going to open token lottery instead, and that's going to be token lottery. This is so that we can use the program, and then I'm just going to copy and paste this right here. This is so that we're using the program from Token Lottery. Now note, this might be different than other tests that we've done throughout this bootcamp. We're going to use the standard anchor test instead of bank run for this one because we're going to do a lot of funky things with accounts and programs. A fun challenge would be to figure out how to do this with a bank run on your own. But ultimately, it's only a few lines of code difference to get set up. All right. So I'm going to remove these. One other thing that I'm going to do is I'm going to create a provider equals anchor.anchorprovider.env. And then I'm going to set the provider here. This is so that I can grab the wallet, which I'm now going to set as the wallet down here. So we'll set also a wallet, const wallet equals, this is going to be provider .wallet as anchor wallet. All right, so we have the wallet, we have the provider, we have the program. Now we can actually do things with the program. So let's go ahead and do it right here. So I'm going to do const. We're always going to do the instructions first because it's simpler to understand what's going on. So this is the init configuration instruction equals await program dot methods dot initialize config. Now you can see here has an error. Let's go figure out why it's missing. So it's because we don't have that start time, we don't have that end time, and we don't have the what's the last one that we needed? So start, end, and price. So let's go ahead and set those. So we're going to U64, or sorry, new anchor BN, because that's how you set the price, or the U64. We're going to do a few things. I'm going to make the start of 0. We're going to go grab a Unix time from online. That's going to be really high, just so we can test this. So just grab that real quick. Boom. That's really high. Let's make it even higher, so it's way in the future. And the price, let's make the price 10,000. This is 10,000 LAN ports. All right, so we have the instruction. Now we have to actually create the transaction. So const tx equals new anchor.web3 transaction dot add initialize config instruction. Let's see what happened with it. Let's see, argument type of pair writable. Okay, so we're just missing something. That's fine. We can do that. So this is just because it's missing some of the information needed to complete. So let's go add all of that. All right, so the things that we need for this transaction is we're going to need some things from the block hash. So we'll do a block hash with context equals await provider dot connection dot we're going to use get latest block hash. There we go. And now we just need to set everything right here. So the fee pair, we're going to set the fee pair as my wallet. We're going to set, let's see, we're going to set the block hash as the block hash with context. And then finally, we're going to need the last valid block height, which is going to be block hash with context dot last valid block height. There we go. And let's see, all the errors didn't disappear. All right, so we're just still missing something. This is because, let's see, this is missing an add. Let's see. I think it's because we don't have the right information to run this. So let's go back up here. So it's program methods initialize config perfect dot. Oh, it's not an instruction. This is a builder. So we have to actually set as dot instruction. There we go. Everything's happy. Yep. We got the transaction. This is our transaction signature. And now we just have to send it. So what we're going to do is we're going to do const signature equals await provider dot web connection. We'll do it with anchor. So anchor dot web3 dot send and confirm transaction. This will need a connection. So we're going to do the provider dot connection. We need the actual transaction, and we have to need the actual pair as well. So wallet dot pair. There we go. I'm going to add a semicolon just for making it look nice. And then we just do a console dot log your transaction signature. I'm going to go ahead and pull this one out because we don't need that until afterwards. Let's run it. So anchor test. One thing I'm going to do is I'm going to run a separate local test validator. So we have, let's actually remove that. Kill terminal. I want a specific type of terminal. I want my ZSH, not just a plain bash terminal. So separately, we're going to set up a local test validator. So if I run local Solana test validator, it'll run my test validator. And then here, I'm going to do anchor test -- skip local -validator. This is just so I don't have to wait for the startup every single time. Also, we're going to do some special things with the local validator. This will make it nicer. So let's run it. All right, so it failed. Let's go see why it failed. Should not in config. Program error 1004. So that's a custom program error. This is usually, I'm probably just missing something. We're going to do a trick here. We're going to add a skip preflight checks so we can actually read the full error. So we're going to skip it. Going to run that thing again, and then we're going to go check that errors. All right, so let's grab that transaction signature. There we go. We're going to go over here. We're going to go to our Explorer. Make sure that you set it to local. Go look at that transaction signature. You can see here, declared program ID mismatch. Perfect. So that's a better error. Let's go figure out what that means. This is because if you go over into librs, you can see that it says HVX. However, when we deployed, it now is ESFW. So let's go update that. And I believe you have to do it in one other place. Let's go find it. I believe it's in the cargo, or it's in the anchor terminal right here. So that also needs to be ESFW. All right, let's run it. Let's do an anchor build with it real quick. And then we'll do an anchor test. And that way it will start up with all of the right program IDs. Anchor test, and deploy again. We'll deploy to that same program ID. And then pass. So we can see here, if we can go grab that signature real quick, and I'm going to go paste it in here. There you go, success. And when we go all the way down, we can see initialize config, return success, and then it took some compute units. Fantastic. It would initialize our config, it created our account. Now we can move on to the next step. All right, so we've initialized the config. The second thing that we had here, if we remember from our design, is we have the initialized lottery. So there's a number of things, different things that this initialized lottery is going to do. I'm going to move this initialized config over here, and just so we can draw up all the different things that this lottery is going to do, because it's going to do a lot. And it's going to be quite a lot of work as well. All right. So this initialized lottery, right? So we're going to do initialize lottery. It's going to do quite a few things. The first thing it's going to do is it's going to create a collection that is owned by the program. This is because we want the program to have full control of minting more tickets. We don't want to have anybody else have that control other than the program itself. It's a separation of concerns, security thing. That's fine. So create a collection that's owned by the program. This is a lot of work, and this will create mint. So create collection, create something called a master edition, so that you can mint more tokens. Or sorry, this is not a master edition, it's a metadata account. So metadata account. And then we're going to also create verify the collection. All right. And if you go over here, so if we go over to the token metadata docs, we can see here that it's very important to check that this verified thing. Let's see if I can make this a little bit bigger. All right, so this is kind of what we're creating here. We're going to create a verified NFT, which includes the mint account and the metadata account. We're going to have that collection NFT, which is also is a separate NFT that will have a collection, some details, and have a mint account. And then we're going to verify it, which sets this collection metadata in the metadata account to the key equal to the metadata, as well as verified equal true. So this is what we're basically going to build, is these 4 accounts right here. Let's go ahead and start building them. All right, so first thing we're going to do is we're going to create a new instruction. So pub function initialize lottery. This is going to have a new context. We're going to do context initialize lottery. This is going to return a result. I'm going to remove all this extra code. And now we have to actually build out the initialized lottery context. All right, so let's go ahead and throw it all the way right after initialize. We're going to set it right here. I'm going to make my term a little bit smaller. So this is going to be a derive accounts. So and then pub struct initialize lottery. And it's going to have a bunch of different things. So one thing it's going to need is it's going to need